So let's look at the first one here. We want to find the open intervals on which our function is increasing or decreasing. I added a few things here to find the relative extrema, absolute max or min, and critical numbers, just to keep that in mind, make sure we know how to do those too. So to find where it's increasing and decreasing, we have to start by finding our critical numbers, which we have to find the derivative. So when we find the derivative, we get 2x minus 2. To find the critical numbers, we set our derivative equal to 0. So this would be 2x equals 2, so x equals 1. So our critical number would be 1. So when we test numbers in each of these intervals, we're plugging it into the derivative. So I want to test f prime of some number in our interval. So from negative infinity to 1, we could plug in 0. 0 would be in our interval. When I plug in 0 into my first derivative, so I'm plugging it into here, we would get a negative number. So this would be negative. In our second interval, I could plug in 2. Again, we're plugging it into our derivative. When I plug in 2, that would be a positive number. So we would be decreasing in our first interval and then increasing in the second one. So to answer this question, we're decreasing from negative infinity to 1, and then we're increasing from 1 to infinity. Since we're decreasing and then increasing, that would make our point here a relative max or min? A relative minimum. So our relative minimum would be at 1 comma. How would we find the y value? Plug it into the original. So we would plug it into f here. So this would be 1 squared minus 2 times 1, which is 2. So we get negative 1. Sometimes with these questions, it could give us a interval that we're talking about. So it could say from -5 to 10. Find your absolute max or min. Then we would also have to put these numbers on our interval here. So I would put -5 and 10, which would change the intervals that we have, but we would want to test these numbers too. See where your highest y value, highest y value would be an absolute max. Smallest y value would be your absolute min. Question? I made it up just to show you. Sometimes it might give you from this interval to this interval. You'd want to test your endpoints. So I made up these endpoints just to show you, but you'd want to test your endpoints and you want to test your critical numbers. If it was asking for absolute max or min.
What do you mean test? Do you mean like plug it in, right?
Yeah.
Okay.
All right, let's look at our limit question down here. So limit, if it goes to infinity or negative infinity, you're looking at the degrees of your numerator and your denominator. When the numerator is higher than the denominator, our limit's either going to go to infinity, or in this case, since it's negative here, our limit's going to go to negative infinity. If our degrees are the same, so for the next one right below it, they're both x to the third power, what do we look at? The coefficients. So here, our limit would be what? 4 over 1, which would be 4. Perfect. If the denominator was greater, let's say I had the limit as x approaches infinity of x squared over x cubed, this would be 0. So similar to the first question we did, it gives us our function and we want to find the critical numbers. So to find our critical numbers, we need to find our derivative. The derivative of x would just be 1 I would change this to be 4 times x to the power of -1. Our derivative here would be -4x to the power of -2. Or if you wanted to rewrite this, it would be 1 minus 4 over x squared. To find our critical numbers, we set this equal to 0 and solve. So I could move the 4 over x squared to the other side, so we get 1 equals 4 over x squared. You could cross multiply. We get x squared equals 4. Take the square root, so x equals plus or minus 2. So these would be our critical numbers. For B to find where we're increasing or decreasing, we do the same thing that we did in that first question. I want to make my intervals here. So we've got -2 and 2. One other thing that we have to check here, we want to see where it equals 0, but also where it's undefined. Where would our derivative be undefined? At x equals 0. Since we have a fraction, our denominator cannot equal 0. So we would also have to add 0 to our number line. Bless you. Bless you. Then we have our intervals from -∞ to -2, from -2 to 0, from 0 to 2, and 2 to infinity. And we are plugging in values into our first derivative to see if it is positive or negative. That'll tell us where it's increasing or decreasing. Then you can use your information that you found where it's increasing and decreasing to find the relative extrema. If it goes from increasing to then decreasing, this would be a maximum. If it goes from decreasing to then increasing, this would be a minimum. I think this was the answers. I might have them backwards, but plug it in, test it. I'll post the PDF of the answers. So here we have a definite integral. We want to find our antiderivative, and then we'll plug in. So to find our antiderivative, add 1 to the exponent, divide by the new exponent. So we would have 3x squared divided by 2 minus 2x. If this was an indefinite integral, we'd put plus c, but since we have values on our integral, we're going to plug in those numbers. So we start by plugging in the top number. Bless you. 3 gets plugged in. We have 3 over 2. 3 squared would be 9. Minus 2 times 3 would be 6. Minus, then we're going to plug in 1. So 1 squared would be 1 times 3 halves would be 3 halves. Minus 2. So we got 27 over 2. Minus, I'll change this to have a common denominator, 12 over 2. So that would be 15 over 2. Minus, here we need a common denominator. Makes this 4 over 2. So -1 over 2, which would be 16 over 2, which gives us 8. You guys can use a calculator for the test. I think there might be like 1 or 2 questions where you need it. The rest of it you could do without. For our integral question here, if we were to expand our binomial, if we were to do 3x cubed plus 5 to the 6th power, we'd be here all day. So we want to see if we can find a pattern. If I make whatever's in my parentheses u, let's see if I have the du for it. So let's let u equal x cubed plus 5. So du would be 3x squared dx. So I have an x squared dx, but I'm missing the 3. So if I put a 3 in here, what else do I have to do? Put a 1/3 on the outside. So I have 1/3 times the integral of 3x squared dx is going to change to be du. And then the x cubed plus 5 would be u. So I have u to the 6th power du. So now we can take our antiderivative. We add 1 to the exponent, divide by our new exponent. So this would be u to the 7th power times 1/7 times 1/3 plus c. So we get 1/21 times, we got to plug back in the x's. So x cubed plus 5 to the 7th power plus c. Find the area of the function over the interval from -5 to 5. So when it asks us to find the area, we're just taking the integral of it. Integral is our area. So from -5 to 5, those would be our bounds. So the integral of 48 minus 12x squared dx. We have 48x minus, this would be 12x cubed over 3, which would simplify to 4x cubed. So then we'd want to plug in 5 first. 48 times 5 be 240 minus 5 to the 3rd power would be 125 times 4 be 500 minus, when we plug in -5, we would get -240. Then we have -4 times -125, which would be positive 500. This might end up being 0, but that's fine. 240 minus 500 be -260 minus this would be positive 260. Not 0. Perfect. So this gives us 520, -520. So that would be our area. So area is just the integral. It'll ask you to find the area from one number to another number. It could either write it like this, or it could say from 0 to 2, like this. So you just take the integral between whatever interval that it gives you. If this was asking for the average value, just to refresh our memories here, we would multiply it by 1 over b minus a, where this would be our a and this would be our b. So 1 minus 5 minus -5. Or 1 over, sorry, 5 minus -5. Which would be 1 over 10. So we just multiply it by 1 over 10. That would be how we find the average value.
That's the only difference?
Yeah. So to find the average value, you just multiply it by 1 over b minus a. On the next page, I added a question. So let's find the derivative of a log function. So first thing we want to do is simplify our log. This is log base 6 of 3x minus 5 to the 1/2 power. Any exponent that I have, I want to make it a coefficient. It's going to be finding the derivative a lot easier when it's a coefficient. That way we don't have to worry about the chain rule and then simplifying at the end. So when we make this a coefficient, we have 1/2 log base 6 of 3x minus 5. So to find the derivative of our log, 1/2 is just going to stay out front, times whatever we're taking the log of goes on the bottom, 3x minus 5. The derivative of that's going to go up on the top, so it's the derivative of 3x minus 5, 3. And then what else do I need to do when it's a log? I have log base 6. What do? We divide it by the ln of 6. If it was an ln question, an ln derivative, you don't have to do anything. You don't have to do anything with the ln because our base would technically be e and ln of e is just 1. But when it's a log, we got to divide it by the ln of the base. So this would be our answer. We could probably simplify it a little bit more. 3 over 2 ln of 6 times 3x minus 5. In this step, we haven't found the derivative yet, so it's not like we're multiplying and then subtracting. We're just expanding our log, so we're moving the exponent to become a coefficient. In this step, this is where I found the derivative. On the next page, I added 3 questions here. So some integral practice. So to find the integral of 5e to the power of x dx, if we have a coefficient that's being multiplied to the whole thing, we can just move it out front. That way we don't even have to worry about it. This is 5 times the integral of e to the power of x dx. What is the antiderivative of e to the power of x? E to the power of x, perfect. So this would be 5e to the power of x plus c. Remember, when you're doing integrals, you can kind of think about it after you find your answer, take the derivative of it, see if that gives you the original question. So you could always check your work that way. For the next one, we can split this up. We can find the integral of 10x to the 4th power minus the integral of 3 dx. So I just put a dx on both of them, but we're just finding the antiderivative of each one separately. So we add 1 to the exponent and divide by our new exponent. So this would be 2x to the 5th power minus 3x plus c. And again, to check your work, you just take the derivative of this, see if you end up with the question. Next one, let's change this to be an exponent. So we have the integral of x. What would our exponent be here? To the 1/3 power dx. Perfect. Same thing that we were doing before. Add 1 to the exponent, divide by the new exponent. So when we add 1, we'd get x to the 4/3 power. When we divide by 4/3, we'd get 3/4 plus c. Next page, we're finding the derivative. So for number 1, we have to use the product rule because we're multiplying here. So this is our first and our second. So the first would be x. I'll write it here. Product rule is first times the derivative of the second plus the second times the derivative of the first. So our first is x times the derivative of the second would be e to the power of negative x times -1, perfect, times the derivative of the exponent, so times -1, plus the second, which would be e to the power of -x, times the derivative of the first. What's the derivative of x? 1. So a couple different ways you can simplify it. Look at your answer choices, see what they look like. They might not pull out a GCF, they might, so just look at your answer choices. We could simplify this by pulling out e to the power of -x. We'd be left with -x plus 1. It could just have it written as -x times e to the power of -x plus e to the power of -x. Could be written either way. So just look at your answer choices. For 3, how would we find the derivative of an ln function? What goes in our denominator? Ax to the 3rd power minus x.
And then the derivative goes in the numerator.
Derivative goes in the numerator, so this would be 24x squared minus 1. Do we have to do anything else? Nope. So that would be our derivative. If this was a log, let's say we had log base 6, like the other one, we would also have to divide it by the ln of 6. But when it's just an ln, you don't have to do anything extra. For For our derivative of an exponential function, what would we do?
It's just the exponential function and then multiply by whatever's in the exponent.
So 6 to the power of negative 2x times what? Negative 2. Do we have to multiply by anything else? What? The ln of 6. Perfect. So this one's different than an e to the power of negative 2x. If it was just an e, we wouldn't have to do that extra step and multiply. But if your base is anything different, you got to multiply by the ln of the base. We can simplify this, but just look at your answer choices and see which one matches. This might simplify to negative 2 ln of 6 times 6 to the power of negative 2x. They could make the coefficient an exponent. So this would be ln of 6 to the power of negative 2. They could actually evaluate it. Ln 6 to the power of negative 2 would be 1 over 36 times 6 to the power of negative 2. So all of these would be correct answer choices. Just look at your answer choices and see which one matches. If you don't have this one as an answer choice, they may have simplified it further. So I added this one to the review. So let's find the derivative. Our derivative would be 5 times e to the power of 2x times what? What are we missing? Times 2, times the derivative of the exponent. So this would be 10 e to the power of 2x. No, because it's e that has the exponent. 5 is just a coefficient. Let's do our integral here. So we have 9 to the power of x. So our integral of an exponential function, keep the exponential function the same, but what else do we have to do? When we find the derivative, we multiply. So what do you think when we're doing the antiderivative we would do? We would divide by the ln of 9. Because think about it. If I were to take the derivative of this, I would have 9 to the power of x times the ln of 9, which would cancel out with the dividing by the ln of 9. So we just have 9 to the power of x. So you can always check your work just by taking the derivative. So here, to find our antiderivative, we divide by the ln of the base. Then we need to plug in from 0 to 1. So plug in 1 first. We'd have 9 to the power of 1 over the ln of 9 minus 9 to the power of 0 over the ln of 9. So this would be 9 minus, what's 9 to the power of 0? 1. So 9 minus 1 over the ln of 9, which would be 8 over ln of 9. This would be like the one question that you would need your calculator for. So just plug this into the calculator. All right, I added 2 more on the bottom here. So another integral question. We want to change this to be an exponent, and I'm going to move it to the top. So I have 2 times x to what power? Negative 1/2, perfect, dx. So then we add 1 to the exponent, divide by the new exponent. So this would be x to the 1/2 power, divided by 1/2. So 2 divided by 1/2, we would keep change flip. So this would be 4 plus c. Now it could be written like this. It could be 4 times the square root of x plus c. The next one says find the particular solution for f of 0 equals 6, and it gives us the derivative. So if it gives us the derivative, we want to find our original function. So I need to find the antiderivative, or the integral of 3x squared plus 5. So we can just find our antiderivative of each term separately. add 1 to the exponent, divide by the new exponent, so this would be x cubed plus 5x plus c. So this would be f of x, because we found our integral of the derivative, so it's now just f of x. If we were to find f of 0, we're going to plug 0 into our x's. So we have 0 cubed plus 5 times 0 plus c. And what does f of 0 equal? 6. So just set it equal 6 and solve for c. So when it's asking for the particular solution, it wants you to find what your value of c is. So this would be 0 plus 0 would be c equals 6. So our particular solution, we just plug 6 back into our function. So f of x would be x cubed plus 5x plus 6. All right, let's look at the limit as, it gives us alpha here, but you can just call it x. So as x approaches 0, sine of 5x over 3x. What would our limit be here? 5 over 3, perfect. No math involved, just look at it. Just to practice, so to give you an extra question, let's say we had the limit as x approaches 0 of tangent of x over 5x. So there's two different ways you could solve this. You can change tangent to be sine over cosine, or you could use L'Hopital's rule. So if you plug in, if you use direct substitution and you get 0 over 0, you can use L'Hopital's rule. So if I were to plug in, tangent of 0 would be 0, and then 5 times 0 is also 0. Since we get 0 over 0, we can use L'Hopital's rule. So we have the limit as x approaches 0 of, we're finding the derivative of the numerator and the denominator separately. I don't know how many times I said this and people still did the quotient rule in the last test. So our derivative of tangent of x would be secant squared x, and the derivative of 5x would be 5. So then when we plug in 0, secant of 0, on our unit circle here, this would be 1, 0. So secant of 0 is 1 over x. So 1 over 1 would be 1 over 5. So that would be your answer. I'll give you guys the unit circle. But that's the only thing that I'm giving you. So again, if direct substitution does not work, if you end up getting 0 over 0, use L'Hopital's rule. Find the derivative of the numerator and the denominator. Or you could, if we wanted to, we could have changed this to be sine of x over cosine of x over 5x. When we keep change flip, I could make this sine of x over x, which we know is 1. So then I have 1 times 1 over cosine, or 5 times the cosine of x. Cosine of x is also just 1, so this would be 1/5. You could do it either way. All right. So we're finding the derivative here. Since we're adding, we can just find the derivative of each term separately. So our derivative of negative x would be what? -1. Awesome. Plus the derivative of tangent of x would be secant squared. So that would be our derivative. For the next one, x cubed times the cosine of x. Here we have to use our product rule since we are multiplying these two together. So the first times the derivative of the second plus the second times the derivative of the first. So our first would be x cubed. What's the derivative of cosine of x? Negative sine of x. Plus the second would be cosine of x times the derivative of the first. What's the derivative of x cubed? 3x squared. Perfect. Now the answer could take out a GCF. It might not. So just pay attention to the answer choices. If we were to take out a GCF, it would be x squared. So we'd be left with negative x times sine of x plus 3 times cosine of x. Questions here? Let's look at the one right below it. So here we're subtracting, so we just need to find the derivative of each term separately. What's the derivative of cosecant? Cosecant, cotangent? Yes. It would be negative cosecant cotangent, but since we already have a negative there, it would turn it positive. So positive cosecant cotangent. Minus the derivative of sine would be cosine. So this would be our answer. I don't think that the answer choices really simplify that much more, but if this didn't match to one of your answer choices, you could simplify it. This would be 1 over cosecant goes with sine, times cotangent is cosine over sine, minus cosine. So we do have a cosine as our GCF that we could take out. So this would be cosine. And then 1 over sine squared, since we're multiplying, minus 1. Or cosine times cosecant squared, minus 1. But I think that the answer choices just leave it like this. It may simplify a little bit, but I don't think so. I added another question here. So to find the derivative of our absolute value, anybody remember how to find the derivative of an absolute value? The absolute value goes in the denominator, so we have 5x minus 10, and the absolute value of 5x minus 10 in our denominator. What's in our absolute value goes up top, so 5x minus 10 would go up top. But we also have to multiply this times our derivative of the inside. What's the derivative of 5x minus 10? 5. Perfect. So you'd have 5 times 5x minus 10 over the absolute value of 5x minus 10.